Okay, so let's say we have this equation, which is an example of something that's called a Bernoulli equation, which has nothing to do with Bernoulli's equation, except that one of the Bernoullis did this and that. Another one did that. Okay, or maybe it was the same. Huh?
How many Bernoullis were there?
There was Jacob, who's the main one, and Daniel, called him Danny, and Jake. You know, Jake and Danny, to those who knew them. You know. Those of us who knew them. They kind of overlapped Benny's time. Benny Franklin. Okay? But they were a little younger. But their dad was around, I think, I remember right. I don't know. Were those guys brothers, or was one of them the dad? Now, wait a minute. It's hard to remember your old friends when you've made so many new ones. Okay, so anyhow, that aside. Okay, I want to make a transformation. Okay? I want to transform the equation to variable v, which is y to the n. Okay? Now, if v equals y to the n, then what does y prime equal? Well, I can take this and do derivative for both sides, right? Derivative with respect to t. So I can write, well, okay, v prime equals y to the n prime. Obviously, v equals y to the n, right? And what's y to the n prime?
With t being the variable?
Yeah, so what's that?
Is y the function?
Y is a function of t.
Okay.
That's implicit from the equation, right?
Yeah.
So what's the derivative with respect to t of y to the n? Well, chain rule. You should totally understand that because you did implicit differentiation last year. Okay? Y is a function of t, so this is a composite of y with the nth power function. Okay? So it's like f of g of t, where g is the nth power, where f is the nth power, and g is your y function, right? So this is like this is an f of y of t. F of whatever its variable, aardvark x, whatever, being the nth power, right? maybe a little confusion here, because this prime goes with the variable of f, right? I don't want to use t here, so I used x, okay? I could have used y, but then that would have been confusing too. So it's confusing no matter what, but you just sort it out, okay? So that if you're doing f prime of y of t, this becomes n times y of t raised to the n minus 1, okay? Or n y to the n minus 1 y prime, which is what I wrote up here. There's another way of seeing that this is what it is, and it's very important to understand this. It comes up all the time, okay? If you just write the derivative of y to the n as n, y to the n minus 1, you bypass the chain rule.
Yeah, I couldn't remember how the chain rule works with implicit differentiation.
Well, review it. Get it firmly in your brain because you're going to be using it. Okay? It's a very important technique. Okay. To an extent, in this course, you need the idea to understand this change of variable. Okay? Which is what we're doing. We're changing the variable from y to v. Okay, well, okay, so okay. What we want is y prime, right? We want to express y prime in terms of v. So what's y prime have to equal?
V prime over n y to the n minus 1.
Okay? And reciprocal of y to the n minus 1 is y to the 1 minus n, negative of the exponent. Okay? Well, that's great, but this still has a y in it. We don't want any y's in this equation, so we don't want to replace y prime with this, do we?
Well, we still have v equals y to the n.
Okay, so how can you use that?
Well, we have y to the negative n.
You want just a variable b, an expression in terms of the variable b, right? So I'll say expression in variable b, right? Okay. How are we going to do that? You're on the right track. What do you think?
I don't know how we'd get rid of all the y's.
Well, you got a relationship between v and y here, right?
Yeah. Seems it would get more complicated than.
Maybe a little, but not much. I mean, if v equals y to the n, then what's y equal?
V to the power of 1 over n.
To the what?
Power of 1 over n.
Yeah. So, very good. So, well, v equals y to the n, so y equals v to the 1 over n, right? And we take that and we plug it in for y here, and what do we get? Y prime equals 1 over n times v prime times v to the 1 over n raised to the 1 minus n. Okay? And what's that? What's v to the 1 over n raised to the 1 minus n? What's your rule for power of a power?
You multiply them.
Yeah. Well, that should be automatic. See this, and it's, okay, I'll multiply those powers.
Have a good weekend.
Put the v prime out on the end. And how would we express v to the 1 over n to the 1 minus n?
V to the...
Don't do like the typical pre-calculus student would do and cancel out the ends. That's why I forbid canceling in that course. Since you're tutoring it, I want to reinforce that. You wouldn't do that, I know. I've never seen you do that, I don't think. Okay? I've seen you in a lot.
I've done a lot of boneheaded things.
Well, yeah, so do I. You know, I do it every day. I did one a while ago, but of course I have no working memory, so I forget what it was, so it must not happen. Okay.
That's v to the 1 over n minus 1.
Could be. Okay. I'm going to write it as a simple fraction. It's going to be easier to deal with. Okay. And that is exactly what you said. You know, 1 over n minus 1, right? But generally easier to do algebra with just a rational exponent rather than, not necessarily. Depends what you're trying to do. Okay, so anyhow, you have this, right? Well, now, can we write that equation?
What's y to the m? I know what y prime is and y. What's y to the m?
It's the mth power of y.
Okay. Yeah.
If v equals,
It's just an exponent.
if v equals y to the n,
I'm sorry, there's way too much noise coming from across the hall. I mean, there isn't, it's not, nothing wrong with it, but it's more than I can handle. It's not particularly raucous, just a kind of a roar. I'm obliterated what you were trying to say. What were you saying, Alexander?
I was going to say that like v would be 1 would be to the power 1 over n, but that's not right.
Well, v,
Because I was thinking back to v equals y to the power of n.
well, I mean, you've already established, since v equals y to the n, that y equals v to the 1 over n, right?
Yeah.
And we want to transform this into an equation in v.
So y to the power of n would be v would equal v to the power of n over n.
Yeah, exactly. Very good. Okay, so we can replace y prime with this.
I forgot about that one.
And what are we going to replace y with?
V to the power v to the power of 1 over n.
And what are we going to replace this by?
What is that?
Well, you just told me y to the m, to the m over m. Wants to be a y no matter what I do. Okay?
Mm-hmm. That looks a whole lot worse.
But
It'll just be
the
a
key
minus
is
here.
you get to choose n. So it gets easier, it gets better. Okay? So we can, first of all, just to get that n out of the way.
Yeah, if you let n equal 1, then you'll get sort of easy.
Okay.
We get this, right? I just multiplied everything by n.
Okay, yeah.
Something doesn't look right. It's not possible that anything is not right. Okay, so even if it isn't, I've never gone through this and done it right. I always screw up something, and often with laws of exponents, I keep nagging my pre-calculus students about. It's real easy to get careless. Okay? Okay, so anyhow, we have this, right? Well, do we really want something in front of v prime? Not if we want to get something that looks maybe like something we could solve. So what do we do? What step do we take to get that out of the way? What would we multiply by this to get 1?
The reciprocal of that exponent?
Yeah. We multiply by v to the n over 1 minus n, right?
Yeah.
So we get n v to the n over 1 minus n, p of t, v to the 1 over n, equals n v, okay. And we got to be careful because I'm multiplying, and I'm going to want to multiply that exponent by m over n, but I don't multiply, I add, right? Because I'm multiplying and I add the exponents. So when you get into this thing and start doing the algebra and, you know, haven't done it in advance and get up here in front of a class and you're kind of stupid anyway, it's real easy to do that, okay? And I've done it more than once. So it's just a matter of paying attention and being careful. And you get v to the n over 1 minus n plus m over n. Okay? Now what exponent do I get here? Those are n's, that's an m, right? I'll keep this the way it is. I could have done all that in one step. Maybe should have. I mean, if I was actually doing it, I would have done it all in one step. But I wanted to kind of show one thing at a time. Okay? Whether that was a good idea or not, that's what I did. Okay? Now to add these, well, I need the common denominator. I need this. I put all this over common denominator. Okay. Now, we're out of time. This equation becomes simpler if I choose n so that this is equal to 0, which will make this into something else. Or if I choose n such that this exponent is 1, then I just have a linear equation, right? And if that does the right thing to this, I get an equation that I can actually solve. Now, I'm not sure I wrote that equation down right, but that's how the change of variable goes, okay? Whether this works out or not is not relevant to the steps you take in changing the variable, okay? So when we do the Bernoulli equation, which would have typically a y to the m and that times some function, which we usually call q of t, turns out we can transform the equation to a linear, non-homogeneous equation. Okay, it's not a linear equation because of the y to the m. We can transform it to a linear equation in V. Okay, the steps are like this. And the algebra is just plain old algebra. Just got to do it carefully.